Cool. Good evening, everyone. As the talk has already been introduced, so I'll tell a bit about myself. Myself, Prakhar. I'm working as an engineering manager at Sharechat, and I have been working with software since 2015. And I can say I've been lucky enough to work with some of the great leaders in this industry in my current company at ShareChat and in my past companies at Hotstar, which has helped me understand how what is the importance of platform in the software cycle, right? Why is it required, and why one should why an organization should focus on those areas, which we'll discuss today. So for today's agenda, basically we'll discuss about the ShareChat startup journey. This is required to understand the need of platformatization at an organization like ShareChat. Uh, sorry. We'll also go through how we as a DevOps team has uh, made developers self-sufficient to suffice their infrastructure need on a day-to-day basis. Then we'll go through like what solution we have built, which is Atlas, the internal developer platform that we have built, and then we'll measure the impacts and we'll go through the learnings also. Cool. So ShareChat, right? It was founded in 2016. The founder started with the idea of building a chat app, and if you see today, a lot of new innovations are happening around the chat apps itself using the LLM models. Interesting, right? So they had idea to build a chat app. Eventually, we they end up building a platform where developers can share their content and consume the content in their local languages. Currently, ShareChat ecosystem has multiple apps. One is ShareChat, then Moj, there is Vibely, and there is one more coming, which is QuickTV. Uh, and once we launch ShareChat, we get good amount of traction from users. People love the idea where they can consume content in their native language. They can share content in their native language, and which has resulted in getting ShareChat as a third largest ecosystem currently after Google and Meta. Uh, so basically, from a product perspective, basically, if you see, we have a platform where you can consume content, and there is an option to monetize on your content through the platform. And sharing is the core construct here. So basically, uh, any WhatsApp message that you see, right, on most of the more WhatsApp message that you see on your groups, like which are good morning or greeting message, chances are they are generated from ShareChat itself. Uh, so the major thing in content, right? When you say like you have built a platform where developers or users are sharing content and consuming content, the main thing is the relevance of the content, right? There is a huge content for everyone, and not everyone likes all the content, right? So the platform or the platform or the app that you are using, the s- its responsibility to serve the relevant content so that users keep themselves engaged, and they keep finding coming again and again on the platform, and they can like entertain themselves. So to provide all these features, it requires heavy infrastructure, you can say. Like currently, if you see, we basically serve around 1 petabyte of new data generated every month on the platform itself from the users. So it's quite interesting. Uh, there is also one more interesting story I have to share. Like back in 2020, right, when just I think before COVID or during COVID, when the COVID hits, TikTok was banned, and uh, there was from the leadership team, we these guys have final identified like there is a need of a short content format which users like. There is a long content format already available in a OTT, but there was uh, gap in terms of serving content between long content format and then the message based content that you share. So the short content format like reels, uh, since the TikTok was banned, there was a scope, and we identified that opportunity, and like we built the Moj app, which provides short format content. We released the Moj app within just 1 week for the users. We just had once the TikTok got banned, next week the Moj app was uh, available for the users to consume. So it was interesting, and there were a lot of traction we have gained on that uh, the new format of which we started serving to users, and we never turned back after that. Uh, so it all looks good, sounds good as a story, but when you what we have realized, like when you develop a product, right, with quite velocity, or you have to meet the targets, or you have to make sure like you are first in the market, and you are trying to identify the market fit for your product, right? um, Developers or people usually take shortcuts, which is okay for that need of that, because that is the need of the hour at that time, right? So because you need to first identify what you are trying to serve to users, are they liking it or not, right? So you take shortcuts, you make sure you are first in the market, you are ahead of your competition, and then you serve it. And then once you start getting traction, what happens, you keep building new product new features on top of the product, which keeps your customers engaged on the platform, so you increase the retention and other things, right? So now basically we'll see like what a typical product lifecycle looks like, right? uh, you get a you think about something that you want to build, you define the timelines. The timelines comes with uh, the involvement of engineering and product and leadership team, like this is the time where we want to release this feature, or this is how the feature should be released. Once the product timelines are finalized, then you start the development, where the engineering kicks in. You start the development of the product. You identify what all needs to be done, what all needs to be built. And while you are developing the product, um, somewhere in the development cycle, the cloud and infrastructure requirements kicks in. Like you have to serve your uh, product that you are building to the consumers, right? You have to deploy it on some cloud in-house, or some any cloud, right? So these requirement comes up, and for example, any application that you are creating that might need a SQL bucket, that might need a um, GCS bucket. Multiple things might be required, right? So you need these requirements, and developers usually get blocked there at that junction of the development where they need to interact with cloud for fulfilling their requirements. And since, as I mentioned, right, you keep building new products, so new features and new requirements keeps coming in. So basically these two section, if you see here, development and cloud infra requirement, these are the areas which suffers a lot when you want to build very fast, and you want to like uh, release things quickly, and the backlog keeps piling up there. So in today's talk, we'll cover this area. We'll not cover how for the deployment part, but how we as a team has improved the workflow for this cloud and infrastructure requirement kicks in. Okay, so whenever someone says like I need to deploy my service, I need these resources, I need pipelines for those services, the first thing that comes up is reach out to DevOps team, right? You either have a centralized team, or you have specific folks within the team who have some better knowledge or expertise in those areas, and they help unblock you, right? So we were also like that, but the today's story is more about not just as a DevOps engineer, but how we as a platform engineer has changed the culture within the organization. So we discussed about the product life cycle, like how the requirement comes when deployment starts, and then some cloud requirement kicks in, right? Now we'll see the other side of the table, where how things happen when the cloud requirements kicks in, right? What all usually happens. So basically, during the development, the requirement kicks in. Usually, developers create some tickets and wait for some help. They create there are some ways or multiple ways in which they can reach out to the team via the support tickets, via the Slack messages, via the emails, in multiple ways, right? So they just go there, and whatever is the standardized company process, they follow that and create the tickets. Now on the tickets are created, and there are, like, since you don't have any automation and there are a lot of things that you are building, your company is in a building mode, a lot of things comes up, sometimes in parallel, sometimes within a day, within a week. So things gets piled up at your SRE or DevOps end also, because they have to handle a lot of resources, a lot of requirements that are coming up from the developers. So and as a DevOps or a SRE or a platform person, what you realize is, hey, every day I have to do the same thing again. Why can't let's build some automation around that? So whenever you get a requirement, you think about, let's build a automation around it. Then what happens? There is a pressure from developers, or there are always timelines, right? You don't have infinite time to just do whatever you want to do. So you have to finish things in quick time. So there is a pressure coming from developers, there is a product timelines, everything is there. So at that point, usually the first instinct is, okay, this is the requirement came, right now let me fix it, then we'll think about automating it. And one thing I forgot to mention, DevOps or SRE or platform team folks not just work on the tickets, they have their own tasks also, right? They have to manage their infrastructure, they have to manage their networking, they have to improve the security. A lot of things are there, right? So they keep doing these things and the tickets, and this is how the cycle keeps going on and on. And then again, the devs have to build a lot of things. They again goes through the development process, and this cycle goes on and on. So basically, around 1.5 year back, we were also stuck in around 1.5 2 years back. We were also stuck in that cycle, and what we realized is, hey, this is not gonna scale. You can't every day just come and dedicate some time to solve these tickets. I kid you not, we within a team 2 years back, what we used to do is, like, we used to dedicatedly spend 2 to 3 hours per day, sit together and go through all the tickets and identify what are the high priority tickets, let's solve them, then do the other things. So this was not helping us out, right? And the folks who are working on these systems, they will start losing interest, because they have to repeatedly doing the same thing again and again. Today you are creating some automation, sorry, today you are creating some resources, tomorrow or day after tomorrow you will get same type of resource creation for different person. So these are all manual things that you have to keep doing again and again. So at that time, what we decided, okay, hey, why not start building IDP, which is an internal developer platform, where we provide a way for developers to do all these niche works that they need to do. Obviously, debugging won't be happen at IDP, but basically you want to create some resources, you want to get cloud access, you want to create some, if you are deploying on Kubernetes, some Kubernetes configs you need, secret management you need, right? All these things you need. If you are using some mesh or something, you need some configs for those also, right? So what we decided, why not start building a IDP and onboard developers on that IDP, and then they can do things on their own. If they are stuck, they will reach out to us. So we started thinking about it, but there are some challenges, and there are, based on those challenges, we picked some strategies, what we should do. It has been iterative. It's not like a first time when we start thinking about it, we reach to these points, but this is what we have realized, and this is what we have followed for building our IDP. So challenges, if you can see, like, always the manual work feels fast. You got some task to do. At that time, you back of the mind, you will think, hey, let's automate this flow. But you don't have time to automate it, right? And small automations will not gonna work. Like you can have automation for one thing at one place, the other thing at another place. That's not gonna scale. You can't ask developers to, hey, if you want to create some resource, you go there. If you want to get some access, you go there. And that will create a chaos across the developers. Eventually they will end up creating tickets only, and you will be using those automations only. So it beats the purpose, right? uh, the other thing is, like, you get a lot of tickets and you are working on a lot of stuff, right? uh, so to build any platform solution for your organization, it's going to take some time and some bandwidth of your team also. So, and it's going to impact some other things that you are already working on. Maybe it's the number of tickets that you are solving, they will reduce, or the other projects that you have picked on, they will reduce. So you have to, what we realized is it's always harder to justify what you are trying to build and why you want it, because from outside DevOps team, it looks like things are working fine. They are able to solve it. It's just a bit of lag is there, which they will improve. So the first strategy that we have picked is, like, so if you think about a IDP solution, right? Um, the what all you can do a lot of things on the solution, on the platform, right? But the thing that we prioritize while building a solution is, what are the critical flows, like where we get a lot of requests. So we analyze all the support tickets that we get in last past 1 year or 1.5 year. We realize, like, hey, these are couple of things which user interact heavily, and they quickly want those things. So we prioritize those flows. uh, and the other thing that we focus on is, we try to make the thing functional instead of making it more fancy in terms of better UI and fancy colors and all those things. We build a basic system where we just made sure the work that is supposed to be done is seamless, but the UI or the forms can be old school. So that is what also we made sure. And we try to build it iteratively. Obviously, as I mentioned, right, you can't build everything at first, and you can't be like waiting for a long time to get everything built and then tell our users to start onboarding it. It will be difficult for users and for you also to justify things. Okay, so with these strategies and technologies, we build our IDP, which we call Atlas. The name refers to, like, the catalog, like the word says Atlas, right? You can find anything on your world through Atlas. Similar ideology we have here. You can come to Atlas, you can find each and everything within the organization, which which team is doing what, where the cloud resources are, who is getting what access. All these things you can manage through Atlas. So we'll go through the technologies that we have used to build this platform. So for IDP, the most critical thing is the platform that you are using. Earlier when we started, we thought of building the IDP from the scratch itself on our own homegrown. But we faced a lot of issues because there are a lot of mappings, a lot of integrations and other things that you need to do, and you have to build everything from scratch, which are already available with Backstage. So basically, we use Backstage as a platform for our IDP, and Backstage is quite flexible in a way. It provides you a UI out of the box, and it has some constructs of its own, but you can tweak them, which we did. And it provides a plugin based mechanism where you can just, to serve your purposes, you can just write your own plugins and integrate it with the Backstage, so that everything is served in a way your organization want, and not in a way Backstage suppose, right? So it's quite flexible in that way. Now basically, in terms of workflows, so the workflows kicks in because each and every activity that user do, right? For example, creating a resource, creating a Kubernetes config, updating a resource, getting cloud access, any other configs that they manage. So all these converts into a workflow, and that workflow then executes these things. So one thing is, like, in IDP, you don't need low latencies APIs, right? You don't want to serve your users in, like, If you serve your users in 1 second instead of half second, it's fine, but the thing should be done. Like for example, if you are creating a resource, it's okay to take half second extra, but it should make sure like the things that you are doing are perfect, because these are like not that dynamic requests that you get, but these are the like the way you create them, and they should be fault tolerant and they should be reliable. Like when users submit something, they should have a confidence that hey, I have submitted something, it should be done. So we started workflows with our own internal via calling services internally and managing the states and other things. Then we realized like there is a great solution already available, which is open source, which is Temporal. So we use Temporal for our workflows, and this gives you a fault tolerant approach to create workflows, manage workflows. And now control plane is the heart of the platform, where, for example, let's say you are creating a resource, right? How the resource will be created, where the state will be managed, all these things are there. So for control plane, we use crossplane. It's a great tool which I personally feel it's quite flexible, and it is Kubernetes native, so no extra learning on top of what you know about Kubernetes or YAMLs is required. So that is what we use for the control plane. And for utilities, we use Slack for notifying users and other things. Now for so that these were the technologies that we use. The features that Atlas currently supports is cataloging. It supports the resource management. It supports the access management. It supports the secrets and config management, and it supports the ownership. Like it makes sure like the for any resource or any config that you create, there is a correct ownership associated with that resource. So for cataloging, if you see like the first thing any user has to do is like create an application which reflects any service and job in Atlas. And this application can have cloud resources, they can have cloud configs, they will have maintainers and collaborators, and they will have other applications linked to these applications if there are dependencies between applications. So if you see here, like this is just a sample example that I have just created on our test setup. So you can see there is a DevOps application which inherits, which has Atlas application. So Atlas is part of DevOps. There is Nexus, which is our in-house service mesh, which is part of DevOps. And furthermore, within Nexus, within DevOps, there are a lot of applications. There are applications under observability also. So whenever you come to an application, you can go to this hierarchy and you can understand like what all things this team or this application is doing, or this segment of the organization is doing, what all they manage and they own, right? So resource management is the cloud resource management that Atlas supports, and it is cloud agnostic. We support multi-cloud resource management. So and we created a layer between users and the cloud, where developers doesn't have to care about what are the terminologies they use in cloud, or uh, how they create resource in different cloud. We have abstracted it out. So we abstracted resource into two forms. One is basic form. This is how the example basic form looks like. You just have to provide environment, cloud, which product you want to create, which project you want to deploy, and some labels are there, and you can add additional labels. The based on the product that you have selected, like you want to create a SQL, you want to create a VM, or you want to create a PubSub, the dynamic form kicks in and it asks you for some fields that is required to create those things, and it is standard across multi-cloud. So within back what we do is like we translate these information and convert it into the cloud specific configuration, but here for users it's the same form. And you can see these are drop downs, so users doesn't have to worry about what VPC to use, what subnet to use. And it also gives us control to keep the company standards. Like for example, if we want to disable some machine types in some region, right, we can do it from backend, and users will not be able to create those resources, instead of just following up with users and teaching them or making sure they are not creating these things which are not required for the company. So if you see the resource management flow, the user will come to Atlas and go into any application. Atlas will make a call to RBAC service, uh, asking, hey, this user is trying to create some resource in this application, is it allowed? RBAC service will respond back with yes or no. If it's a yes, then user will fill the form and the request will go to our resource management service, which we call Odin. Uh, since the services are internal and people have access to our internal APIs, we have extra layer where these services again make call to the RBAC service and validate, okay, hey, this user is trying to create this resource, is it okay or not? And then this resource management service converts the user input and make them into a cross-plane format KTS objects. And based on the environment and project there where they want to create those resources, it applies in that cross-plane cluster. And eventually, resource management calls a metadata service which contains all the overview of an application and tells, okay, hey, in this application, this resource is created. And then metadata service serves the content, at least the listing part, to the Atlas. And then once the things are applied on crossplane, crossplane does call the internal APIs of the cloud and create resources in the cloud. Uh, for the access management, so access management happens with two parts. One is the application access management, which we discussed, like if a user is allowed to do something in the Atlas application or not. So this is how the form looks for the Atlas application management, where the application maintainers or pod admins can add these users and assign some roles to them. They will have a control, fine-grained control at what features they want to give access to users. The other access management that we support is cloud access management. And this is again agnostic of cloud. Wherever you want to get access, you can just request here. This supports accessing for users, service accounts, and the groups, Google groups that you create. Uh, this also support time-based access management with auto expiry. And so for users and groups, we have this time-based mechanism where you will get access for some time only, and you can renew via the utilities that we discussed, which is Slackbot. So you'll get a notification beforehand, okay, hey, your request is going to expire. Would you want to renew it or not? So that your workflow is not broken, and you don't have to come to platform again and again just for request access. Right. This also supports resource-based access. For example, some resources like DBs, buckets, or tables. For those resources, you don't want to give access to all the all the tables, all the GCS buckets, or all the cloud buckets, or all the SQL instances. You want them to select specific instance, and then they will get access for that instance. But there are some resources where it's okay to give access, like for VMs or for PubSubs. You can give access to all the PubSub, and they will use whatever PubSub they want to access. So wherever we keep the actual data, we make sure we have a resource-based access there, and there is a protected access also. For example, if someone manages those resources, they can add like, hey, if someone wants to access these resources, they have to get approval from me first. And the workflow is, whenever you request for those access, the approval flows goes to them via Slack, they approve, and then you get the access. So yeah, this is majorly about the access management. Then for the config management, at any application level, you can go and create secrets and config maps. These secrets and config maps directly get syncs with the Kubernetes secrets and config maps where your applications are deployed. Atlas doesn't understand these secrets and config maps. They just keep these things and doesn't store these things. They directly integrate with Vault and stores everything in Vault, and it is fetched from there to be served in the Kubernetes. And we have a version control for the secrets and config maps also. For the ownership part, basically whenever any resource is created via Atlas, they have proper labels like which team, which application it is created in, what is the team of that application, which pod it is created in. So all the required labels which are required to identify, hey, where this resource belongs to, who's the owner of that resource, they are uh, available there. And there are a lot of workflows like moving resource from one application to another, moving application from one team to another. So whenever these activities happen, the resources are updated dynamically on the cloud in the real time. So users doesn't have to make changes for that. And these resources help us in cost allocation and like distributing the cost to specific teams and pods. So these were the features, something that we have also built. So any IDP that you build, right, or any automation you build, still people will reach out to DevOps for some help, or maybe they are facing some issues in accessing Atlas only, or accessing some flows in the Atlas itself. So what we did is like, and a lot of the interaction that we have is via Slack, at least in our organization. So we built a Slack bot, Slack-based ticketing system, where developers will just write something in the Slack, tag that bot, and based on that, it will create a ticket behind the scene, and it will help us to solve those tickets. And they can just discuss there within the thread like a normal Slack conversation. So they don't have to go to different platform for raising tickets and following tickets there. As I mentioned, right, there are a lot of configurations which we can handle from the backend, like which machine types to be allowed to be for the creation, which projects to allow, which subnets, VPC. A lot of things are there. So we have an admin portal where we can control all these things, and it's quite easy for for us or admins of the Atlas to control these, to manage these things. Uh, and temporal, I think we already discussed, like this is what we use for the workflows. Uh, so this is this is what we feel is quite apt for the situations where we feel where we were put in when we were building the IDP. There were a lot of questions why we are building it, and you can't build end-to-end fully working IDP in first shot. There are issues that you keep fixing them, right? So for the impact, basically what we have seen is like once we have the IDP available for users with good amount of functionalities, there is a drastic reduction in the support tickets. It has reached to around 10 or 20% of the support tickets which they were used to be earlier. uh, when everyone started creating resources via Atlas, the cost allocation and cost tracking became a piece of cake for us, because then we don't have to worry about, okay, hey, there might be some resources which don't have labels. How will we track that cost? And it will be, it will not be tracked in the system, right? With this IDP, we have also we also provide cloud access at a granular level, where they just have to they can define what access exactly they want, and it can be a resource based or global IAM level access, but it is at a granular and we can control with the time. And it helps in generating the audits for us also, like let's say you have 20 projects, so what all accesses, which all users have in each project. So to generate that report, it becomes just a one-click solution for us, which we need quarterly or annually. uh, so the learnings that I feel are that the learnings that we have felt while we build these things is, first thing is we need to understand the core problem, what you are trying to solve. And whenever you build the solution, it will always be difficult for you to make it adaptive for users, right? The other thing is, what we have seen is like, uh, you should not provide any solution which requires lot of changes for users. They will not like it. You can't just start saying, okay, hey, yesterday you were doing this thing and now today you have to start working on this, and whatever you have created earlier you have to move them here. No, they will not do that. You need to make sure like things are synced properly, whichever state they were in, to the solution that you are providing. And you have to think incrementally. You can't build everything in one shot. Start with small things, share it with developers, get feedback, and based on that you can keep iteratively building features on top of it. Yeah, I think that's all I had to share with everyone. If you guys have any questions.
There is one question.
Hello.
Yeah.
Yeah, thank you so much for the session. So for the Atlas platform that you're using, in general, since it is doing so many things at a time, how are you taking care of the administrative side of access management? How are you dealing with your secrets?
Uh, so I just want to clear one thing. By administrative side of access management at a Atlas level or at a cloud level, because we have access management at two places.
I don't mean access management to your users. I mean you as the platform owners. How are you dealing with it?
So basically, we have different roles within the platform. Okay. So there are some admins, which are very few in number, who have access to control each and everything in the system, and others they have to get granular level access to perform any actions on the system. Hello. Yeah, it is better now. Should I repeat?
Yeah, please go on.
Okay, cool. So basically, I was saying like we have different roles within the Atlas. Like the admins are there, like which is our team primarily. So we have access to all the resources across applications, and we keep reviewing our access also, like who all have admin access. And for any access that needs to be done, for example, a new pod is created or new application is created, you have to give access to them, right? So the by default, whoever creates these pods or teams, they will by default get the admin access for that pod and team who have created them. But then it's up to them to add people within the application or within the team, so that they can control who can create resources within their application. So now it's their developers responsibility to make sure they have correct set of people, correct access within those areas where they manage.
So you're handing it over to the owners to take care of it.
Yeah. So it's all up to developers how they manage it,
Hmm.
who they allow to create resources within their applications. Auditing is always there,
Hmm.
but still, like once the thing is done, then it's done, right? Even after auditing, you can just track it back. But to stop this at a first place, we make sure like the pod admins or the application owners, as I mentioned, right, there are collaborators and maintainers. So whoever are the maintainers are the owners of the applications. They manage this application and they make sure like correct set of people are added there and they are removed if they are not there. So that is how they manage these things.
Got it. Thank you so much.
Yeah. Cool. Uh,
Any
I think it works. Hello? No. Sorry. Sorry? Yeah. All right. So my question is around the data model for the catalog actually. So I understand that you're using Backstage, right? And Backstage has a fixed data model like systems, that one, right? So are you following the same thing, or did you ever have to create a custom data entity?
Hello. Yeah. So we tried creating custom data model for our use case, but what we realized is it's too much of work because you have to touch each and every ecosystem of Backstage, and primarily the reason we use Backstage is for UI and the search functionality that they provide.
Got
So basically, what we have done is like, and Backstage also provides a great feature where you can whatever data model that you have in your system, there are parsers written where you can pre-process and post-process your data, and you can inject and write a layer. Actually, you can write a layer which translate your data model to the Backstage data model, and you can feed the data to the Backstage. So that is the approach that we use right now.
Got it. Okay. So just a follow-up question, right? So when you define a service, right? You said application. I'm
Yeah,
not sure if you know
application.
what. Okay. When you say application, is it like bunch of microservices or?
So, so whenever you create an application, you define a type.
Mhm.
The type can be a service, job, or a application itself.
Got
So when you say application, then it indicates there are multiple other applications which will be combined
Mhm.
to serve the purpose of that application. For example, DevOps is an application, but DevOps is not a microservice.
Okay.
DevOps has a lot of other applications like
Right.
Atlas, but Atlas is again not a microservice. There are a lot of other services. So the leaf of that hierarchy is always a service and job, which reflects to a KTS workload or any other workloads that is running on the cloud or in other places.
Got it.
But the service application of type application, it sounds weird, but application of type application is a combination of services and jobs which work together to serve the purpose of that feature.
Understood.
You can say.
Yeah.
Yeah.
Thank you.